The sequence is 4, 6, 10, 16, ... and the pattern is continued. Part 1, verify that the sequence is not arithmetic. Part 2, show that the sequence is quadratic. Part 3, if the general term or the general formula of this sequence can be written, Tn equals an squared plus bn plus c, find the value of a, b and c. I'll say, so part 1, verify that the sequence is not arithmetic. So the difference between 4 and 6 is going to be 2, because term 2 minus term 1 is going to be 6 take away 4, which is 2. So to get to 4 to 6, it's a difference of 2. And then to get from 6 to 10, it's a difference of 4. So term 3 minus term 2 is going to be 10 minus 6, which is 4. And clearly 2 and 4 are not equal, so the first differences are not constant, hence the sequence is not arithmetic. Part 2, show the sequence is quadratic. So what we need to do is find the first difference and then the second difference. So our sequence is 4, 6, 10 and 16, there are terms. To get from 4 to 6 we're adding 2. To get from 6 to 10 we're adding 4. To get from 10 to 16 we're adding 6. 2, 4 and 6 are known as the first differences. To get from 2 to 4 we're adding 2. To get from 4 to 6 we're adding 2. These 2's are known as the second differences. Since the second difference is constant or the same, so they're both 2, the sequence is quadratic. Part 3. If the general term of this sequence can be written, Tn equals an squared plus bn plus c, find the value of a, b and c. So the a from our formula, the an squared part, is going to be equal to half the constant second difference. And we got the constant second difference to be 2. So a is going to be equal to half of 2. And half of 2 is going to be 1. So a is going to be equal to 1. So we're going to take term 1, which is 4. So t1 is equal to 4. And we're going to sub into our formula. We're going to swap the a for 1. And since we're interested in term 1, we swap the n for 1. And that n for 1 as well. So you get 1 times 1 squared is just going to be 1. B times 1 is going to be b. C stays as c, and equal to 4 stays the same as well. So that 1 at the front there came from the a, which we got to be 1, because a is half times the constant second difference. So it's half of 2. And half of 2 is 1, so that's where that 1 came from. A is 1. Then we put 1 in place of both of the n's because we've got term 1. And it's all equal to 4 because term 1 is 4. So we have 1 plus b plus c equals 4. So we're going to bring the 1 over the other side, and 4 minus 1 is going to be 3. So we get b plus c is equal to 3. Then we're going to take the second term, which is 6. So term 2 is equal to 6. So we're going to do the same thing using this formula. We're going to swap that a for a 1, because we got a to be equal to 1 over here. We swap that n for 2. We swap that n for 2. And it's all equal to 6, because term 2 is 6. So 2 squared is going to be 4. It's going to be 1 multiplied by 4, plus 2b plus c is equal to 6. So we're going to say 6 minus 4 is equal to 2. So we've got 2b plus c is equal to 2. So now we're going to take both of these equations and we're going to solve them simultaneously. Because remember, we're trying to ultimately find the values of a, b and c. We have a already. A is 1. We need to now find b and c. So we're going to solve these two equations simultaneously. Now at the moment I have plus c, which will give me 2c, but I want them to cancel out. So I'm going to change the signs of one of the equations. So I'm going to change the signs of the top equation, but it doesn't really matter which one I do. So technically I'm multiplying this by minus 1. b multiplied by minus 1 is minus b. C multiplied by minus 1 is minus c. 3 multiplied by minus 1 is minus 3. Minus c plus c now cancel out. Minus b plus 2b is b. Minus 3 plus 2 is minus 1. So now I have b is equal to minus 1. So I've got my a value to be 1, my b value to be minus 1. Now we need to find the c. So I'm going to take one of the equations, doesn't matter which one, I'm going to go for this one, b plus 3 equals c. I'm swapping the b for minus 1. So it's minus 1 plus c equals 3. So then 3 plus 1 is going to be 4. So c is equal to 4. So I have a to be 1, b to be minus 1, and c to be 4. So my general formula is Tn equals an squared plus bn plus c. I swap the a for 1. So it's going to be 1 times n squared is just going to be n squared. I swap the b for minus 1. So it's going to be minus n. And I swap the c for 4. So it's going to be plus 4. So the general term, or the formula, or the nth term of this sequence is going to be Tn equals n squared minus n plus 4.